Hello students, I hope all is well. I'm here with another tutorial. This one is for Udacity's front-end nano degree. This is for their classic arcade game. Now, what I have here is the rubric, and what I'm going to do is go through each of these sections and the specs, help you guys understand a few concepts, and help you prepare your project for submission. Now I have my project here loaded in the browser. I'm going to compare it to the rubric just so you guys can see what they're expecting when you submit it, things you need to have, and how to do certain things. Now I'm going to start off by cloning the game. I'm at the GitHub where it actually gives the starter code. I'm just going to download it. Once I download it, looks like I already have it. So let me just extract it. One moment. I'm going to go to downloads. Extract a new copy. Now I have Atom text editor here. Now I'm going to open the brand new one up in the browser. Now when you get it, it's going to be blank. There's nothing going to be here. If you open your DevTools, the first thing I do is look in the console to see what's going on, because any errors or warnings will be put in the console. So I'm not seeing anything, so I'm going to think, okay, let me check what's working, what's not working. And it looks like we have a few errors that Udacity has. So it says reference error, all enemies is not defined, right? And we can see the call stack from resources to engine, JS, this line right here. And we have another error, player is not defined at app.js 45. So in this project, Udacity gives us some asset files and a game engine and an app file. You don't really have to touch anything in this folder. These are just images that Udacity gives for the game. The styling, you don't have to touch that. There's not much there anyways. If you look at the resources, basically this file is caching all of the images in a resource container. It has load, get, on ready, is ready. This is to help the game run smoothly by not loading images all the time. It's just going to use what's in the cache. So there's that. And there's the game engine. Here, what Udacity is doing is setting up some global variables. It's going to create a canvas tag. You can get the context. It's going to set the width and height. And it's going to append it to the body. So if we come back and come to the elements tab, we can see that canvas is right here. Now they have this function main, and inside of it, what it's going to do is create a variable called now and delta ticks, or DT, and it's going to subtract now from the last time and then divide that by 1000. So this is pretty much what's going to represent that smooth transition as far as like updating your entities when you create them. Now, after it creates the now variable, it's going to call update and pass in that new DT variable and call render. And last time will equal now, right? And then it's going to call window dot request animation frame. And this is what's being called constantly. This is what's creating the loop. If I were to log let's say now. And if we refresh the page, okay, so let's first take care of these errors. So Udacity assumes that we're going to create an array called all enemies and player object, but we didn't define those yet, so let's go ahead and comment those out so we can get a few things started. Now, looking at the call stack, it says engine line 94. All enemies is not defined. So at line 94, all enemies is not defined and is being called within this update entities function. And that is being called inside update. So I'm going to go ahead and comment this out for now. And player is being called, player is not defined. So if I try refreshing this, that works, right? So once we comment out update entities, get the game board showing. Now if we, all of these is not defined, engine 153. So it's calling update, it's calling render. Let's take a look at render. Now inside render, this is what's creating that game board right here. We don't need to touch any of that. And it looks like render entities is calling this function right here, and it's just gonna call render for each. So we can go ahead and comment this out because we don't have any of the enemy or player objects defined. So if we save that, our errors are gone and we can see that DT variable that I was trying to log, which is right here, right? Now, that's basically what request animation frame is. It's a function that's always running, basically checking changes in the browser. So whenever in your browser and let's say you scroll down, that's a change, and the request animated frame is going to call a function which will repaint the browser and show those changes. So every time you scroll, anytime something happens, it's going to request animation frame which happens in the background, and it's going to show changes. So Udacity is using that for the game loop, right? Now, I just loaded this new project just to show you how to get started. I'm actually going to go back to my code and show you how I did things, which is right here. It's JS Arcade Game. I'll go ahead and refresh this, or rather exit out. Alright, now here's my game. I made the game board longer and just added this feature to change the character whenever you come to a certain spot on the page. It just randomly selects one of those character images and then resets the position, right? And also added jewels. If we collect one of them, you can see the score increases, their hearts, their enemies. If you hit one, you lose a life. The game is over once you lose all of the lives that you have. One, you see game over. Game over is true. I can't move the characters anymore. Game is over. Now, let's go over what's being asked in a rubric. So, number one is error free. So make sure that you have your console open and you can see that there are no errors and the game is working as intended. Now, it says player cannot move off the screen, vehicles cross the screen, vehicles being players, collisions happen logically, not too early or too late, vehicle collision resets the game, something happens when the player wins, right? So in this particular case, there's no real end. You go as far as you can until the game is over. That being when you lose all your lives, right? Now, object-oriented code, game objects are implemented using JavaScript's object-oriented programming features. We're going to talk about constructor functions and prototypes, and basic documentation, which is your README file, comments, and code quality. Now, coming back to the first section, which is the game functions, let's go ahead and talk about what's going on. So, don't mind this. This is just my particular app. What I want to talk about is the enemy object and the player object. Now, JavaScript is a prototype-based language. It's not class-based. So basically, what that means is JavaScript doesn't really create objects from a class. Rather, it just clones it from another object. And whenever an object is cloned from another, it saves a reference to wherever it got information from, called its prototype, right? Now we're creating a constructor function here, right? Constructor function is simply a function that allows you to create new types of objects. So if we were to look inside, let me just come to the bottom and just say window.log game equals function, and all I'm going to do is just log player and all enemies, right? Now let me log the game. Our game is not defined. Sure it is. I just did it right here. We know that log game equals function app. Not sure why it's not working. Window.log game. Come to sources, JS, app.js. Oh, I'm sorry. This is my online repository. Let me open it up locally. Alright, now let's try it again. So come to console, do log game. I call it, we get player and we get enemies. And we can see inside the prototype the constructor for this object player. You can see that it's being called by we have struct players, constant player equals function. Oh, okay, so it's not a named function. So let's go ahead and give it a name. So function player of our enemy equals function enemy. You save that, refresh it. I'm going to call it again. If I go into the prototype, you can see the constructor function is being called by that player function, right? Now, inside the prototype of this object, we can see it has handle input, render, reset position, update. The object itself doesn't have those properties, but it's inheriting it from the constructor function, right? And that's basically what you will have to do throughout this entire app. You just add methods to the prototype. That way, whenever you create a new instance, it will inherit those, right? Now, for the enemy constructor, what I did was I have sprite, or this dot sprite, which is just an image or a reference to that image. This dot x will be the x position. This dot y would be the y position, and this dot speed will be the speed in which it will move across the game board. Now, inside the update method of all enemy objects, we're going to increase the x, right? So we know that in the canvas tag, the corner is in the top left. As the x increases, so it will increase to the right, and as the y number increases, it will go down, right? So when x increases, the object being painted on the canvas will move towards the right. So I'm going to say plus equals, basically adding on this dot speed times that delta tick, and that is what's allowing the objects to have that smooth animation moving, because it's being called with every animation frame from the browser. So that is what's going to move the enemy objects. If this dot x is greater than the size of the canvas, right, we're just going to reset its x back off the canvas on the left side, which is negative. And then I'm going to create a variable called SumSpeed, which is math.floor. It's going to be a random number times 4 plus 1, which is the same as 5. Now I'm going to say this dot speed is 60 plus, this is just me particularly, you can just say I guess this dot speed will be the same as this here. I'm adding this extra logic to have the enemies move faster as the score increases, but not everyone's going to implement a scoring system. You can just simply leave it like this, where this speed will equal just a random number, and that speed will get multiplied by the delta ticks. So if I were to save that, it should work just fine normally, right? Now, I'm going to explain this portion a little bit later, but as far as updating, that's how you can get the players to move. Now, if I were to comment this out, they're not moving, right? So this particular section is what is going to help you move your enemies. So basically, you just want to increase the x by the product of the speed and the delta ticks, which is being called constantly through the game engine. Through update, for each enemy, so we're going to call enemy that update, and we're going to pass in that delta tick. And once the x position goes off the canvas, then we're just going to reset it to off the canvas on the left side. And then we're just going to give it speed, a random speed. So that way, whenever it starts over, it's going to be at a random speed. It's going to be different each time. So this one starts off fast. Now it's moving really slow. These start off at an average speed. And then now it's actually really slow. And it shouldn't be doing that. So let me put back. Let's say this dot speed is 60 times some speed. Alright, so that's about normal. So as far as this portion again, we're just going to do math floor. We're going to do a round number of a random number times 5, and then we're going to multiply some speed by 6. And that's what the speed will be. Now, inside the render method, Udacity already has this. Basically, it's going to get this image from the resources, right? Resources is basically inside engine. At the end, it's going to load all of these images, right? So that way it's going to help the game run smoothly. So all you have to do is just do resources that get, and then pass in a reference to the image that you want to get. So Udacity already has this. Enemy that handle input, I'm not sure. I don't think Udacity gave this. I'm not sure why I have this. So you don't need that. And that's basically the only two, I'll say, methods enemies need, right? Now for the player constructor, I'm going to say inside of it, this sprite is that one of the characters, this X and this Y, will start it off here, right? Basically setting the X and Y coordinates. H step, which is horizontal step, is basically stepping left to right. Now for the V underscore step, that's for stepping vertical, up and down, right? So if I press up, down, it's only going to move by 83 pixels. Now I don't really need player.update, I just have it defined because it's being called inside the engine. I can just easily, let's just get rid of it. I don't need it, so I'm gonna just get rid of it here. Save it. No errors. Still working. Now I have a method for resetting the position. I have a method for rendering it. This one looks exactly like the enemy's render. We're just gonna take its resource and put it on the canvas tag. Now Udacity does give you a listener at the end, so document that add event listener key up, and it's going to listen for keys you press on your keyboard, and it's only going to call a function if you press either one of these keys. 37, 38, 39, and 40 are key codes for the arrow direction pad, right? So if key code is inside these keys, it's going to call player that handle input and pass in the key we pressed. So when this function gets called, which is right here, I'm going to do a switch case, basically determining what to do based on what key we get. Now if we press the left key, then I'm going to do a ternary. So if this .x is greater than or equal to h step, basically this is just the logic determining where they are on the board. So if they are less than what they're able to move, then they must be at the edge. I'm not going to allow it. If it's not greater than, then I'm not going to allow it. If it is, then we're going to allow that step. I'm basically doing that for each direction. Same thing for right. If it's less than or greater than a certain amount, right? 5 meaning 1, 2, 3, 4, 5. We're going to allow them to increase the step, else we're not going to allow them to move. Same thing for down. If they're already at the top, then we're just going to reset position. I'm sorry, at the down. If they're already at the bottom of the screen, we're not going to allow them to increase their Y coordinate. Otherwise, we're going to add a step to it. Now, in the case of moving up, if they reach a certain point, then we're going to what I did was based on my game, just update the score. But in your case, if you just want to pass, all you have to do is just reset the position, and then let's just say you call the alert function saying, hey, you won the game, right? Now, as far as that project, that will be basically it. I added extra features just to do it, but as far as passing the game, you only need to create the enemy and player classes, right? Now, object-oriented code, we are leveraging the keyword this. We're using prototypes, which is JavaScript's prototype-based paradigm project, or I'm sorry, programming language. The game is running free. You can't move off the screen. You can collect certain objects on the screen. Once you reach the top, you reset position. So that's basically it. I think I covered everything. Oh yes, this portion right here. So this is basically the collision logic. Now, everything on the canvas is on a pixel basis. So when you say that the width is 505, or rather 707, 606, we're saying that the pixel is, or the canvas is 707 pixels wide. And each of these items being drawn on the canvas is at the center 1 pixel. The canvas or JavaScript isn't really accounting for other, I guess, pixels around its center point, and we have to account for that. So although the image for these bugs are about, let's say, 40 pixels wide or something, JavaScript only knows it at its very point, right? Because if that was the case, then these enemy bugs would be returning to the side once the tip reaches the edge, but it's not. It's going to wait till the very center of that image passes the point that we specified. So we have to account for the space around that focal point for the images that's being rendered on the canvas. So inside that, I have a variable called enemy x left max, right max, top max, and bottom max. And basically it's going to be its x position and some space around it, right? Now, once we have these variables that represents the space around it, or the actual size of the image for the enemies, I'm going to do an if statement. Basically, if player.x is greater than the left max, meaning that we are within its, I guess, range, and we're going to do that for each side, right? If we are within this range here, then that must mean that they are touching. So I'm going to reset position, count the lives, but in your case, you can do whatever logic you want. But basically, you want to account for the space around the image. Although it may appear 40 pixels, JavaScript is only counting the very middle of it. So what you can do is create variables that will account for the space around it. So this.x minus 70 would be the space to the left of it, plus 70 would be space to the right of it. This.y minus 60 would be the space on top, and this.y plus 60 would be the space under it. So if I were to just leave my character here, we can see that it works. As soon as the enemy touches the player, then it resets the player. Now let's say I did 10 for each of these. Let's see what happens. I'll reset it. And it doesn't even work, right? Doesn't even work. So that's why you have to account for the space, because not only is the spacing around the enemy you have to account for, but also the spacing. So although the character is visually about more than 1 pixel, JavaScript is only counting things on a pixel basis. So the very center of that image is what JavaScript is concerned about. So we have to create these variables that will allow us to like create some sort of range around that focal point. So if I put it back, it will start to work again. Right. So basically, once you have those 4 variables, we would just say if player X is greater than the left max, meaning that we are within this range on the left. If player X is less than the right max, meaning that we are within the range on the right side. If player Y is greater than top max, meaning we are within range from the top. And if player Y is less than the bottom, meaning we're within range on the bottom. Pretty much that little space around the enemy object, that's how we can tell that the player and enemies are colliding. So hopefully that helps. That's the bulk of the rubric. Object-oriented code that doesn't seem too hard, and error-free. There's no errors in the console. The README should be easy. Comments, code quality should be easy. If you use any text editors, you can use a plugin that will format your code properly, follow syntax standards. Any long function blocks, you can add a comment explaining what's going on here, and that should do it. Now, if you have any questions, just leave a comment in the comment section below. I hope this video helps. I hope you all have a good day. Happy coding, and thanks for watching.